I'm going to go to File, New, create a file here. Okay, so the Rhino interface, again, is going to be similar to other CAD programs that you've used. So, for example, AutoCAD, other examples, Inventor, things like that. I'm going to open up the typical screen. So you'll see a top view, a perspective view, front and right. So as you're modeling something in one view, it'll show up in the others. Some basic navigation tools in Rhino. If you use your scroll wheel, it'll zoom in and out. If you hold right mouse button, it'll pan in any of the top or front views. If you hold your right mouse button in a perspective view, it'll toggle in 3D. Okay, so zooming with the scroll wheel, right mouse button to toggle 3D or to pan if you're in 2D. All right, and so you can double click on any of these views to maximize it, or double click to get back. So if I'm modeling something, let's say I'm making a box, I model it in 3D, but it also appears in the other views as well. So top view, front, right. And by default, this starts out in wireframe view. If I want to go into shaded view of this cube, I can right click perspective and go to shaded. I can do that for any of these, or if I want to go into ghosted, now it's semi-transparent, ghosted, you can do that. You can go to Arctic, which will give you kind of a shaded view. All right, so double clicking on this to maximize it. We're going to go through the interface, how it works, how you can pull up commands and get started pretty quickly in Rhino. So Rhino, there's always more than one way to get to a specific command. There's the kind of tabs at the top, right? I never use these, but they're broken up into curve, surface, sub-D, solid, mesh, dimension tools. Those are all here. What I'm going to do also is go through the different ways of getting to any of these. So tabs, you can also find all of those commands through the tabs. So for example, under standard tab, you'll see save, print. All of those views are also available here. So if you look at the car, there's different, if you want to go into elevation view, you can use the drop-down arrow and find the view of the car that you're looking for. In this case, I'm going to go back to perspective view. You'll notice that the C-plane just changed. That's this kind of plane here. That's because we went into a side view where it kind of reset. So to change the C-plane, there is a whole other set of tools that I like to use here. So to pull up a tab like this, so in this case, this is C-planes. To pull that up, I'm going to right click on this open space and go to show toolbar. Here you can pull up any set of tabs that maybe aren't here that you would like to show. So I'm going to pull up C-planes, and I'm going to dock this on the right. You can just click and drag to dock it. And I'm going to set the C-plane to be the top down, so the traditional way of XY plane that we work with. So that kind of brings us to the way Rhino sees the world. It uses a coordinate system, so XYZ model space, where X is in this direction, and you can see this triad at the bottom here telling you which direction is X, which direction is Y, and then Z is vertical. Okay, so Rhino sees everything in a XYZ model space. It's called a Cartesian coordinate system. And down to the very surfaces that are used. So if I were to draw a plane, every surface also has its own coordinate system. So a surface has what's called a U and a V directionality to it. So in one direction, it'll be the U value. In the other direction, it'll have a V value. So those are two different coordinate systems, right? The U and the V, and there's also W, I guess, for the third dimension. So a coordinate system based on a surface, and then a world coordinate system based on X, Y, Z, kind of preset, never-changing coordinate points in the 3D model space. Those are the X, Y, Z values, and then coordinates that can change for the U and the V based on each surface that you were to create. Okay, so for example, just to illustrate that, if I were to type rebuild on this surface, I can rebuild this two-dimensional surface with, or three-dimensional surface with values. So it's asking how many subdivisions in the U direction. It's starting off with 2, right? 1, 2. But do I want to give it 10? And it's giving you a preview of what it's going to look like if it subdivides it in the U direction 10 times, or let's say 5 times, and then 10 in the other. Okay, so anyway, I don't want to get too deep into that, but I just want you to know there's two different coordinate systems, one an X, Y, and Z for the whole Rhino world, and then there's a U, V, W coordinate system for surfaces. Okay. All right, so right now I have two things in my model space. I have a solid object, which the other term for solid objects is called a polysurface, or a BREP, B-R-E-P. So that's what this is. I also have a surface here. So this is just a two-dimensional plane. I can take this cube that I made, and again, I got there by clicking on this box command, clicking once, clicking again, and clicking a third time to create a box. Now, Rhino, when it has commands, you can either click on the icon, you can also go to solid at the top. If you go to one of these tabs, you can go to solid, find box, and you can select how you want to create that box. Do you want to go corner to corner in height? Do you want to just go diagonal like that and create it? But either way, the result is the same. You create a box. I can then select this and type explode, and now each surface can be individually modified. So now this can get broken up into individual surfaces. Okay, so we've talked about solids, surfaces, and I guess we should also start with points. That's probably where we should have started. If you'll notice, you can click on this tab on the left, click on point, drag that in. The other way to bring up a command is to type it into the command line. So you don't have to click. So at the bottom, you'll see this command line. You don't have to click down here and type. You can just start typing. So if I type the word point and hit enter, it'll run the point command. So it'll generate a point. So you can type point, you can type any command, and it'll run it. Just hit enter afterwards. Okay. I guess I'll move this over to show you. Okay, so if I were to type curve, I can then hit enter. Then I can click a series of times and it'll create a curve, and then hit enter to complete that command. All right, so anytime you run a command, let's say I do that again, I'll type this time polyline. That's another command, polyline, enter. Notice it's asking me something. Should this be persistent in closing itself? I'm going to say yes. I'm just going to click on that just to illustrate the fact that that command line is interactive. Sometimes it asks you questions. You can click on it or type Y for yes, N for no to kind of respond while you're creating the command. So notice how I told it yes, that I want it to be enclosed. And then when I hit enter, it's now an enclosed polyline that was created. What if I type that again, polyline, and set this to no? It's just going to create an open polyline, and I hit enter to complete it. All right, so this command line is interactive. As you're working, it may ask you questions. You can respond to it by typing or clicking on it. All right, so we have curves, we have a point, and again, you can just type any of these commands in. I can type box and then start clicking and have a box. I can go up to the Solid Tools tab here, find the box that way, right? You can also get a truncated cone or any of the other kind of primitives that come out of the box with Rhino, right? So from these, you can start manipulating them. The traditional way that most people work in Rhino is they'll start with either points or curves. They'll take those curves, generate surfaces from the curves, and then take those surfaces, add them together, and then generate solid geometry. Okay, there's one other geometry type that I want to explain. It's called mesh. Okay, so a mesh is a series of points that generate a topology or a surface, but we don't call it a surface, we call it a mesh. Okay, so with a mesh, it's based on a series of vertices. So if I were to hit this and type points on, it'll turn on the control points, which I can then select. I also have gumball turned on, which is this triad. If yours doesn't come on, right, every time you select something, the triad comes on here. If that's not happening for you, just turn on gumball at the very bottom here. So if that's not blue, make sure it's blue. All right, so then I can select a certain number of points and I can manipulate these. All right, so these are called control points, and this is a mesh. I won't dive too deeply into mesh modeling. As we start getting into 3D printing, we'll start talking about the benefits of working with a mesh. But you can see how, again, I can select it, type points on, enter, and I can then select and start manipulating these points. I don't have to do it with the gumball, and I can move these. Yeah, you'd select it, then type points on, and then you can start manipulating it.